Hi, this is David Giard, and today we're talking about Windows Azure Storage. Azure Storage consists of tables, queues, and blobs, and a couple of things that are derived from those. When you install the Windows Azure SDK, you do get a few tools that help you to deal with Azure Storage. The first thing you get is the storage emulator, and you can see the storage emulator by right-clicking on the Azure icon on the system tray and selecting View Storage Emulator, and you see this interface right here. What this does is it shows you which of the three services, blobs, queues, and tables, are running locally on your local box. It gives you the ability to start and stop those services. What you'll do is you'll check the services that you want to be affected by these buttons. So if I check just blob and queue and clear table, and then I click stop, it'll stop the blob service and the queue service, but it won't affect the table service. Also, you can reset any or all of these services by clicking the reset button. What it means to reset is it'll clear out all of the data that's in the blob or the queue or the table. And that's really nice for when you're doing testing and you want to get back to a consistent state, so you can easily see what was added during your testing. The other thing is Server Explorer. Server Explorer isn't new, it's installed when you install Visual Studio, but when you install the SDK, you do get this extra node here called Windows Azure Storage. And below that you can actually see the blobs, the tables, and you can open it up, expand it, and see the containers that the blobs contain and the various tables, and you can actually see the data in those tables and in those blobs. Which is nice for verifying that the changes that you make in your code actually do get persisted to the blobs and tables. Now what's missing here, of course, is the queues. I think that'll be coming soon, but it's not there right now. There are some open source and third-party tools that will allow you to look at queues as well. The other tool that's added is the this configuration viewer. There are certain configuration files that are part of your Azure project, and they are stored as XML files. But if you double click them in Visual Studio, you will see this graphical interface here that'll make it a little bit easier to manage if you're not really comfortable with XML. Probably the biggest thing for storage is this settings tab, which allows you to set connection strings and constant values for maybe storing the names of tables or the names of containers for your blobs, and allows you to look that up in code so you can change it between the maybe your development environment and your production environment. Tables, blobs, and queues have some features in common. For one thing, they all expose a REST API, and it's this REST API which means that you can use HTTP URI endpoints to manage the CRUD operations, the create, read, update, and delete operations, to add items to these storage features, remove them, items from them, update items, delete items, and so on. That's all done through HTTP. Now, some people aren't real comfortable using HTTP. Most of us as .NET developers would probably rather use more strongly typed objects. And the good news is that there is a .NET wrapper that abstracts that away and exposes a more strongly typed API for working with that. And I'll show you that. Also, when you're working with them, you always have to have an account. The account points to where exactly you'll find these storage entities or the storage persistent data stores. You can point to a development environment on your local box, and that's supported using it's built on top of SQL Express, and it allows you to press F5 inside of Visual Studio and work with all your data locally, or you can deploy out to the cloud and point to a connection string out in Windows Azure that'll actually point to data stores that are stored on your Azure account, which is probably what you want to do in production. Alright, let's dive into tables first. A few things to remember about tables. Tables are, you've probably heard this term in reference to relational databases like SQL Server. Azure does support a version of SQL Server. That's SQL Azure, but that's not part of Azure Storage. That's a separate thing. The tables in Azure Storage differs from SQL Server in that it is not relational. You can have multiple tables, but you cannot define relationships between those tables explicitly, and Azure Storage will not manage the referential integrity between those tables automatically. If you have any kind of relationships, you'll have to manage that yourself. It is simply a set of key value pairs. There'll be unique identifiers and then a bunch of extra properties or columns that define the entity in each row. It's also important to understand that there's no schema associated with a table. So in SQL Server, if I wanted to add a new column, if I have a customer column, for example, and I suddenly wanted to start persisting a new attribute about that customer, I would have to go in and change the schema ahead of time and add a column just to store that attribute. Not so in Azure Tables. In Azure Tables, I simply can store it and it'll take it. It doesn't really care what the schema is. We'll manage that ourselves. Every entity that you store to a table, or in other words, every row that gets stored there, will always have these three columns: partition key, row key, and timestamp. And beyond that, you can add whatever columns you want as long as they are of a primitive data type. And by primitive, I mean something like string or int or decimal or Boolean, things like that can get stored automatically. You can't store a more complex type like an entire order column within a customer column, things like that. The way that we're going to store them, ensure that these three required columns are always in each entity in each row that we store. First of all, the partition key and row key, these uniquely identify each row in your table. So as you add these things, you'll have to make sure that those values are unique. You can set all of your partition keys to be the same value, in which case just the row key has to be unique. But you want to manage that probably a little bit better. What's important to understand is that as Azure tables scale out more, they can scale out very large, much bigger than SQL Azure, for example. The fabric of Azure may decide that one server is too busy or too full. They may decide to start moving part of your table off onto another node. And when it makes that decision, it'll make it based on the partition key. So it'll tend to keep rows that have the same partition key on the same node, and it'll tend to move rows of different partition keys onto different nodes. What that means to you is that as you're querying your tables, a query among the same partition key tends to be very fast because they're all in the same node. But if you're querying across multiple partition keys, that tends to be very slow because you'll have to search across multiple nodes within Azure. Alright, the way that we make sure that all of our entities have those three required rows is simply by inheriting from this class, this abstract class, the table service entity. And it has those three properties here, those three fields here: partition key, row key, and timestamp. So if we inherit from that, the timestamp is going to get set automatically. The partition key and row key, it's up to us as developers to set those and to ensure that the combination of the two is unique for a given table. So here's kind of an example of the data that you could store in a table. I could insert one row that has a partition key of CAN and a row key of 0001, a timestamp of a given date and time, and then a customer entity which will have these three properties here. I'll say the name is Marvin, address is Milliways, and total revenue for that customer is 100,000. And that'll store just fine. It'll look like there's three extra columns in here: name, address, and total revenue. I could then store another row with the same partition key and a different row key, as long as this combination is unique. That's valid. and the timestamp will get set. And I can change this customer so that it has extra columns. So in addition to name, address, and total revenue, I can add favorite color and hairstyle. It's perfectly valid. I don't have to go in and modify the schema ahead of time. And I can add a third row here. I've actually got an error on here that I'm going to correct real quick. Let's say instead of CAN, I make the partition key US, because this has to be unique. This combination of partition key and row key must be unique, and then whatever the timestamp is. And it's perfectly legal for me to then, even though I've been adding order or customers all along, to all of a sudden throw an order into the same table with completely different properties. Now, I don't recommend that. It's probably a good idea to put different types of entities in different tables. It'll be easier for your code to keep track of that, but there's nothing preventing you from doing so as far as the table itself is concerned. Now here's the code that you'll use to actually work with a table. As I said, you always want to start with an account, and the account is from a connection strings. So you'll have a connection string. You probably want to store that in configuration so you can change it between development and production. And simply this static method, cloudstorage.fromConfiguration, pass in a connection string, or pass in a key to get that connection string, and that'll return an account object. Once you have that account object, then you can use that to create a context object. In this case, it's a table service context object. And it'll do that. The account has a table endpoint and has a set of credentials. And when we pass that to constructor of a table service context, we get this new context object, and it's with this context object that we can start managing the entities in that table. So that context object then, for example, we can create a query to return an iQueryable and use link to iterate through that. We can use this. We can use a link to directly. We can use link as in this syntax here. We've got kind of the lambda syntax where we're looking for everything within a given partition key, or we can use the more SQL-like link to take that iQueryable here and do from e and query where partition key equals some constant and row key equals some value, and select e. That should select just one row, at most one row, because the partition key and row key are unique. And we said dot first or default will return either that particular row, or if the one isn't returned, it'll just create a default for us. We can also use the context to save a row by using the context add object and passing in an entity, and this entity is derived from that from this element here, the table service entity. And then we have to call the context save changes. So when we're actually working with modifying the table, nothing really happens until we call context.save changes. We can delete a row. We'd have to attach entity to the table using this attach to method of context, and then call delete object and pass in the entity. And again, nothing really gets committed until we call save changes. Let me show you an example of this. This is from the Windows Azure Training Kit. First thing I want to point out is that within this XML file, serviceconfiguration.cscdfg, we have a connection string, data connection string. There's a special value called use development storage equals true, and that says that when we create an account based on this, it's going to use the local storage emulator for us. Now, as I mentioned earlier, that we don't, if you're not really comfortable with XML, you can actually go into this right here, and it'll show a nice graphical interface here, and we can see that data connection string there, specify that it is in fact a connection string, not just a regular old string. And there's actually a little ellipses here where if we say use the Windows Azure Storage emulator here, then automatically it's just going to add this special use development storage equals true. If I want to actually use something out in Windows Azure, I'll select that radio button, in which case I want to specify a specific account name and account key that I'll get from my portal, and whether it's HTTP or HTTPS and so on. I'm not going to do that. I'm going to do everything in this demo within the local emulator. So now I've got the data connection string. And then what I can do is I can use that. I can I have something called a message. My message class inherits from table service entity. Right here, table service entity is in this Microsoft.WindowsAzure.storage client namespace. So I've inherited from that, so it'll automatically have the partition key, row key, and timestamp. And I want to add a couple of other things. I want to add a name property and a body property. And then I've got a method here called setKeys, which sets the partition key just always to the letter A, because for this simple demo, I'm just going to always use the same partition key. And the row key will be, I'm going to make it unique based on the timestamp, because my application really can't do more than 1 per second, but it'll go by ticks. So this will always be timestamp. Oh, it actually uses a new GUID as well. So just forcing it to be unique based on this pseudo-random thing here. And then in my code, what I'll do is I have a web page here. And it has a name text box called name box and a message text box called message box that I'm going to enter data into, and I'll click submit, and what will happen when I submit is it'll call that API that I was talking about. I will create an account object, and I'll do so by calling the static method cloudstorage.from configuration settings. I'll pass in data connection string, and then it'll pull out that use development equals true, and it will create an account object. And using that account object has a table endpoint, it has credentials. I'm going to create a new message data service context. And it's that context that I'm going to use to actually update the table itself. So the method I'm going to use is add message, because I want to add a new message to the table based on what the user input, and I'll pull a value out of the name text box, and just to be safe, I'm going to HTML encode that, make sure that there's no malicious scripts in there, and then I'm also going to pass in the text from that the user entered in the message box, the message text box, and HTML encode that. And I actually have a little method here called add method. What that does is it creates this new an instance of this this message entity. And remember, the message entity derives from table service context, so it already has the partition key, the row key, and the timestamp. And I remember that little method I had called setKeys that sets the partition key to A and creates a unique value for the row key. And then I set the name and body property to whatever the user had entered in those text boxes, and I call add object, and I call save changes. And once I do that, then I am this will be added to the table. Call add object. There's the name of the table, and there's the message entity itself. So if we see this, what will happen if I run this? It takes a second to launch the emulator. And you notice down here the emulator now is started here, and in fact I can actually click on this here. Oh, it disappeared on me. Let's go back up to here, and right here I can right click on this and show storage emulator, and there's that storage emulator that I talked about in my slide deck. right here. My web pages or my application is launching in the background. But in here I could, if I wanted to, I could reset, stop, and start everything in here. And then I've got a name here. I'll put in my name is David. And a message, hello. And I click on submit, and it will add an item to the storage here. Looks like there were already a bunch of items in that storage. Why don't I go back into my emulator here, and I'll reset all of my blob queues and tables. Click on reset. Are you sure? Yes, I'm sure. That's why I clicked it. And now when I refresh, I actually have this grid down here. Let me show it to you really quickly. I have on my page, I have this grid here, which is actually data bound to all the messages in the table. But when I refresh this page, I should see that all those messages will disappear. And I'll add that again, David, hello, and I should only see this one message because it's the only message that's actually in the table. And it's unable to connect. Why is that? Let me look real quick and see if my table storage is started. Probably had something to do with me resetting while I was in there. So let me restart the application. And launch again. My name is David. I'll put hello here and click submit. And there's that one item. If I come in here, and let's say my brother Dan is online, he says, hi Dave. And I respond back, Dave. Dan lives in Australia, so I'll speak to him in his own native language. There we go. And it can add things to the table. So how do I know it's being added to the table? Well, why don't I actually look here in the Server Explorer. And in Server Explorer, I have this Windows Azure Storage node. I can open up the development environment, expand tables. And I should have a table called Messages right here. And I can view table. It'll actually show me the data in that table right here. And there's those 3 rows that I just added. You can see that this one was HTML encoded. Name and body are the 2 custom properties that are in here. Here's the timestamp. It got added automatically, and then my set keys, set the partition key always to A and the row key to some unique value based on the current date time. So that's working with tables. Let's move on and talk about blobs. Blobs are a way of storing large objects to persist within Azure. Within Azure, you have really limited access to the local hard drive, and what you do store there, it does not persist. So in other words, if an application or if a virtual machine in Azure restarts, anything that was stored locally is just going to disappear. If you really want something to persist, particularly something large like a video file or a picture or an audio file, blobs are the way to go. You want to store them in there. Blobs are always stored within a container. So we need, as with all storage, we need an account, and we also need a container to store them in. So the code for doing that is, first we need to get the account. This is exactly the same thing we saw before with tables. We've got the static method cloud storage.from configuration. We pass in a connection string. It'll return an account object, and from that account object we can create something called a cloud blob client. In fact, there's a method called create cloud blob client. Once we have that client, then we can call get container reference and pass in the name of a container. In this case, we've hard-coded the word gallery, the string gallery in here, and that'll return this container object. And that's where blobs always live, within a given container. There's no concept of subcontainers. You can't have containers within containers. But we have here container.create if none exists. That's a just sort of a safety method to make sure that we're not working with containers that don't exist yet. That static method will create it, check to see if it exists, and then create it. We're going to put that somewhere, either maybe in the application startup or in the deployment time, something. And then we could set permissions on that container. We can retrieve permissions on that container and so on. In this example here, we're getting a permissions object, and we're setting it to public access. So this means that anyone can access any of the blobs within this container. You can actually, and then we call container.setPermissions. You can actually set permissions on individual blobs, but I would recommend that. It's probably a better idea to set permissions on the container, and then you have a lot of flexibility. You can create multiple containers based on the permissions that different groups have to each of the blobs within those, and that's a lot easier to manage. Just a couple of containers rather than many blobs that you don't even know how many they're going to be when you actually design your application. And then we want to work with the blobs themselves. Then the container has a method called getBlobReference, and using this you can either access it by its name, by a URI, that'll be http:// or by a GUID. So blobs will have any one of these things should uniquely identify a given blob within a container. And so any one is acceptable for passing into the getBlobReference method. And then we could set, before we save the blob, we probably want to tell it what the content type is. Because if we're using it in a web role, we'll want it to tell the browser how to render, how to handle that when it's downloading that blob. So it could be images /x-bing, it could be audio, it could be video, it could be a JPEG, it could be a lot of different things. We'll want to tell it what that is. And then we can actually set metadata on it. A metadata is just a name-value collection. So if we create a blank name-value collection and then set a bunch of name values, like ID is just some unique GUID, file name. We could pull the file name from the whatever file was uploaded to the blob, or we could just set one hard-code one here like this. We could have something called image name, which is distinct from file name. We could give it a description. We could add tags, so they allow the user to search based on tags. And then once we have this name value collection, metadata, then we can add blob.metadata.add and pass in that name value collection. That just becomes part of the metadata of the blob. And then this line right here is a common one you use in a web role, blob.uploadByteArray, and pass in an array of bytes. So if you're giving your users the ability to upload items to blob storage, this is a common way you would do it using this method. And then deleting the blob, once you have the container, you get a blob reference, and you call blob.delete if exists. That just deletes it. You can reference it through the REST interface, http:/, in this case I'm using something locally on my machine, so I've got local storage, that's the name of my account. So this part here is my account. This right here, gallery, is my container, and this is the blob name, image1. And I added this one right here, this example here, to show that you can have an account, the same account, and a gallery is the container, and you can have a blob name with slashes in it to make it look like there is this hierarchy of containers or hierarchy of folders, but in fact that's an illusion. The container is gallery and the blob name happens to have a slash in it. So there really is no hierarchy. You can only have one level of containers. You cannot have containers within containers. Let's go to a demo of this. Once again, I'm selecting one from the Windows Azure Training Kit. And you can download this and see it for yourself. Search for Windows Azure Training Kit using your favorite search engine. And let me just run this here just to show you what it does. In this case, what I've got is I'm giving the user the ability to upload an image to an image gallery. And what I'll do is I can click browse here to go out and select one. Here I've got a let's see, how about this 3D graph right here. Click on open, and I'll give it a name. I'll call it graph, and for the description I'll say 3D graph sample, and tags, how about graph and visualization. Let's separate it by commas. Visualization, and so on here. That'll be part of my metadata. And when I click upload image, what it'll do is it'll actually upload that, add all the properties of it here, and show an actual picture of it right there. And I'm given also the ability to copy that. I say OK, and it makes a copy of it. And all it did is it changed the ID here, and that's about it. I also have the ability to delete. If I click this delete button here, it kind of a confirmation steps up, OK, and I delete that. So that's what it's going to do here. So what will happen is that when I click, I've got these text boxes here, and what are they called? They're called image name, image description, image tags, and then I've got this file upload control here, this image file. And when I click this button, upload image, the code that's going to run is, first of all, I make sure that that image file I've actually selected, the user's actually selected some file to upload, set some status here, and then I call save image, and I'm passing in a unique ID, a GUID, and then the values in those text boxes here, those 4 text boxes, the image name, description, tags, 3 text boxes plus the file upload control. And then I'm also passing in some information that I'm just getting from the image file, and the image file is what is it? I'm sorry, these 4 are all text boxes right here, and this image file is the file upload control. And I'm actually, whatever file that the user has selected upload, I'm going to get some properties of that. So it has a file name, it has a content type, and it has actual raw bytes to that file. So I'm just going to get that information directly from the file that was selected. And I'll pass all that to save image, which is a method down here. And what it does is, first of all, I have to call get container, and then once I have the container, I can call get blob reference and pass in the name of the blob. That gets a reference to a blob, which right now is not persisted. And once I have that blob, I can set properties.contentType equal to the content type of the file that was uploaded. And now I want to set some metadata on it. And metadata is just a name value collection. And I'll set some things like ID, file name, image name, description. These will all be set to, the ID will be set to that GUID that I created, but these other 4 things will just be whatever the user passed in or typed into those text boxes. If they typed in nothing, then I'll just put the word unknown in there. And then I'll add that metadata, this metadata here, I'll add it to the metadata property of my blob, and then I'll call blob.uploadByteArray, and these are the raw bytes, this array of bytes that are part of that file upload control. And that will actually upload the file the user selected and store the contents of it inside of this blob. And then once I've done that, then this gallery gets refreshed, and I simply set, I've got on my page here, I'll show you right here, this is a list view, and the list view has a data source which gets a list of all the blobs. So I get the container, and I call list blobs and some sets of properties of that, and I bind that list of blobs to this list view. And that's all. Now I've already done an example of this here, so if I look in the Server Explorer, I should be able to expand the blobs and see the container that was created right here, gallery. And within that gallery, if I double click it, I should be able to see that one blob right here, and I can click open here, and it just shows me the raw bytes here. If I want to do something more, I don't think I have the option in here to, let's see, if I want to actually see it, about the best I can do, I think if I do a save as, no, I'm not sure what that'll do, but there are other tools that will actually allow me to look at the pictures of it, maybe some open source controls, third-party tools that allow that. Alright, the next thing I want to talk about is queues. This is the final point of Azure Storage. A queue is designed for asynchronous processing. It allows us to place a message onto a queue and immediately get a response, so we continue on with our work, but then provide guaranteed asynchronous delivery of that message to some other endpoint that's monitoring that queue. Here's the common use case for using queues. Let's say I have a web role, and a web role is essentially a web application or a web service that responds to some kind of input. So let's just assume that in this case that it's a website. If I've got some business process on the back end that has to do some long-running process, like maybe check a credit card or save an order to a database somewhere or call a web service or whatever, something that takes some time, what will happen if I try to do this synchronously is a request will come in, the web role will call this business process, it'll take the time to process it, it'll return, and then the web role will return a response back to the user. That might be just fine if you only have one user and you have to wait a few seconds, but when you start to scale and you start to get thousands, hundreds of thousands, millions of users, this doesn't scale very well at all. Every one of those is going to lock up a thread, and people are going to be continually waiting on these processes to run. And that process, in that example, it only took a few seconds. What if that process takes hours? You certainly can't have the user sitting there waiting for hours. So that's not a really scalable model to use. A more scalable model is if, instead of calling that business process directly, the user makes a request, the web role then takes whatever information the business process needs and creates a message and drops that message onto a queue, and then immediately returns a response saying, okay, got your message, carry on. And we have a worker role, and a worker role is kind of like a Windows service. It sits in the background and just runs and waits for things to happen and then responds to them. That worker role then picks that message up off the queue, and that worker role calls the business process, which does its thing. And it doesn't really matter to the worker role how long it takes, because nobody's really waiting on the worker role. There isn't some user waiting for a response. So if things get backlogged a little bit, the worker role will just take more time to do it, and if it gets too far behind, we'll just add more worker roles to monitor this. The disadvantage of this, of course, is that business process might actually return a meaningful value. Like if it's a credit card example, it may return, a credit card approved or credit card denied, and we've lost the ability to immediately return that to the customer. So what a lot of websites will do is they'll accept the order right away, and then they'll check on it. If by chance that credit card authorization fails, it'll then send an email saying it failed. Or if by chance the item, we're trying to fulfill an item that's out of stock, it'll send an email saying, oh, sorry, this is out of stock, it's going to be delayed, do you still want to keep your order? Things like that. So you'll have to have some other process for doing that if there's a meaningful value coming back from that. But other than that, one disadvantage, the advantages are great. This is much, much more scalable because we're not tying up our web role. Web roles can respond very quickly, and therefore we can respond to a lot more of them simultaneously. So how does this queue work here? Here's the code that we use to reference a queue. Once again, this is the exact same code we saw before. We're going to create an account, and we use the status method cloud storage account.from configuration, pass in a connection string, and that creates this account object. And once you have this account object here, we can call create cloud queue client, and this cloud queue client object then is used to get a reference to the queue. It has a get queue reference. We'll pass in a queue name. That's just a string. One thing to be aware of is that queue name must be lowercase. And once we have this cloud queue object, we can call queue.createIfNotExist. Make sure the queue exists before we start working with it. And then we can add messages to that queue. So we can create a message, a cloud queue message, pass in some text to that message, or maybe some XML, something like that, and call the queue.add message to add that message to the queue. And that's how we place messages onto the queue. And some other process will come along and retrieve those messages, and the way we do that is that it would have similar code to create this queue object and have an account and so on, and then we call queue.getMessage, and that'll actually return the first message that's on the queue. So it's a first in, first out. So the first unread message that's on the queue, the oldest unread message on the queue, it'll return that. What'll happen is when you call queue.getMessage, that message then becomes invisible to any other processes. So if you have multiple worker roles that are reading off the queue, then they're prevented from getting the same message, picking up the same message, because the first one that gets it will actually mark it as invisible. And it'll stay invisible for a certain amount of time, and if that timeout occurs, then the queue will assume that the message that the worker role just lost it, that it died, and then it'll become visible again, so some other worker role can pick it up. But your worker role, though, would, once it finishes processing it, would call queue.deleteMessage, and that'll actually remove the message from the queue. Slightly different than the way that the MSMQ works. And here's a demo of this. And this, once again, I'm taking it from the Windows Azure Training Kit, so you can download that and take a look at it. And in this case, if I open that up, I'll press F5 just to show you what this thing does. And all I'm doing here is I'm just giving you the ability to drop messages onto a queue one at a time. Not a whole lot to see here. What I did have is in Windows Azure, I do have the compute emulator that I can open up. And that'll show some trace messages. I have just one instance of web role and one instance of worker role. It'll show some trace messages, and I'm going to close this thing here and just show you the code behind it. First of all, we do have in our web role, we have a data connection string, and I'm using development equals true, and also in the worker role I have data connection string, use development equals true. And in my web role, the default page right here, I've got a text box called txt message and a button called btn send. And what happens is that when you click on this button here, here's the code. First of all, we get the storage account. We've seen this code several times already. Cloud storage.from configuration. It gets that development, use development equals true connection string, and returns storage account object. And then we use that account object to call create cloud queue client, and that queue client, then using that we can this queue client, then we get a reference to the queue. We pass in the name of the queue. Remember, it has to be all lowercase. And then we'll call create if not exists. I don't know if this is the best place to put it here. Probably want to put that maybe in the application startup, or maybe in at the deployment time. But just to be defensive here, we're always calling it every time before we start working it. And then we're going to create a message, and the contents of that message will just be the text box. The text of the text box the user typed in. We'll create this new cloud queue message, and we'll add that message to the queue by calling queue.add message. and then we'll just blank out that code here. So we saw that working, just blanking it out, but we didn't really see what was on the queue. If we want to see what's on the queue, let's take a look at the worker role. And what the worker role will do here is we're just using the trace.write line, and what that's going to do is we'll be able to see that in the compute emulator. And again, we're going to get the account using the static method cloudstorage.from configuration. From that, we're going to get a queue client, and from the queue client, we're going to get reference to the queue, the same queue name, message queue. And then this worker role, all it does is loops forever. While true, it'll sleep for 10 seconds. If the queue exists, then it'll call queue.getMessage. And queue.message will just pull the oldest unread message off that queue, verify that message does not equal null. So if there's nothing to pull off, then that message will be null. And if there is a message there, then we're going to call write. It doesn't really do anything with it. It just writes out information, trace information. And we'll be able to see that again in the compute emulator, and then it deletes the message from the queue and then goes back to sleep for 10 more seconds. So when I run this thing, what I'll do is I'll drop 3 or 4 messages on there. And I'll actually set a breakpoint in here. So if it actually finds a message,